It's time once again for Catalog and Cocktails. This is your weekly, live, honest, no BS, non salesy conversation about enterprise data management with tasty beverages in hand. I'm Tim Gasper, longtime data nerd and product guy at Data.World, joined by Juan.
Hey, Tim. I'm Juan Cicada, principal scientist at Data.World, and it's Wednesday, middle of the week. Time to take a little break and have a drink and chat about data in an honest, no BS way. And today we have an awesome guest because all our guests are awesome. But
So
I'm
excited.
really excited because we're going to talk about so much stuff about data and graphs, and who else would be one of the best people in the world to go talk about this than Emil Eifren, the CEO of Neo4j. Emil, how are you doing?
Welcome.
I am glorious. Thanks, guys. Looking forward to this.
All right, awesome. So if you don't know who Emil is, you've probably been living underneath a rock. So I think you're a man who does not need any introductions. But let's just go start off with our discussion here about telling and toasting. Tell us what we're drinking and what are we toasting for. Emil, you want to start off?
Yeah. So I'm drinking Jämtland's IPA, which is my favorite Swedish. For those of you who can actually see the visual, I'm basically sitting in what looks like a sauna right now. It's midnight here in Sweden, an hour before midnight, and it looks like a sauna. I'm here in Sweden, and this is my favorite local microbrewery, Jämtland's brewery, which it's a region in the northern part of Sweden. And I'm drinking today their IPA.
Awesome. Well, I look forward to going to Sweden one day, and then hopefully we'll meet up and have beers together over there.
And thank you for joining us so late. It feels like a nice sort of evening ambiance you've got going on.
I think it's perfect because I can legitimately drink this without being too decadent, right? It's 11 p.m., right? And whereas, I think when you recorded with DJ, the guest from the last week, it was probably morning for him or something like that. Right?
Hey, it's always 5 p.m. somewhere, right?
Exactly.
It's hard on the West Coasters when they got to drink at 2:00 in the afternoon, right?
Exactly.
How about you, Tim? What are you drinking today?
I am drinking a Vesper Martini. I'm running a little low on some of my liquors. I got some gin, I had some vodka and some lemon and a little bit of Lillet Blanc. So that's what I'm drinking today. And a wine glass because I have no martini glasses. I got to upgrade my game a little bit.
Well, I'm having a vodka soda, but not any type of vodka. It's one of my favorite vodkas that you get in Mexico. So it's a Smirnoff spicy tamarind vodka with grape fruit soda. And that's what I'm having here. So cheers. And I'm going to kick off toasting because I finally launched my book I've been working on for years, and it is now out there. You can go get the book, Designing and Building Enterprise Knowledge Graphs, together with my co-author, Aura Lucilla from Amazon. So I'm cheering to that. Years finally in the making and done. Cheers.
Awesome.
Cheers.
Congrats, Juan.
Amazing.
Cheers to that as well.
So we got our warm-up question here, which is what has changed the most about yourself over the past 10 years? Who wants to start?
Man,
put you on the spot here.
That's a hard one. Tim, how about you go first? Because that one was hard.
All right. Yeah. When I first saw this question about 10 minutes ago, I was like, oh, gosh, what am I going to say? I decided that I'm going to say, my forehead wrinkles, they've deepened quite nicely over the last 10 years. It really gives me a weathered kind of distinguished look, I would say. And you know what I've noticed over the last 10 years? I like whiskey way more than vodka now. That has evolved quite a bit for me.
How about you, Emil? You have one now? Any wrinkles?
Oh man, no, I probably don't. Look, I mean, 10 years, like 10 years ago, I just started Neo4j and I was single, right? And now I'm married, I have 3 kids, and I guess 4 kids, including the company, right? Neo4j. What has changed the most? I feel like freaking everything has changed except for my love for graphs. That one still remains. But probably my ability to go for days, if not weeks, if not months at end with very little sleep. I used to be one of those people who didn't I didn't have to sleep a lot, but I think probably around the time when I crossed into my 40s, now I need a solid 6-7 hours per night, otherwise I fall over.
I'm gonna steal a couple of yours. Like the sleep thing is the same. 10 years ago, I was in the middle of my PhD and I was like, oh, you sleep 4 or 5 hours and that's it. Now
Exactly.
I need to sleep 8 hours, like minimum 8 hours. And that has changed my life. And so life recommendation is go sleep 8 hours. It's a good thing. And I think also my appreciation for wine has dramatically increased in the last 10 years. So that's me. Hey, so let's go kick this off. Emil, honest, no BS question. This whole data landscape, it's bonkers. It's freaking crazy. In your perspective, because you've been looking at this for over a decade now, how did we get here and where are we going? Let's go start with this, and we got more things to go dive in.
Yeah. That is one broad question, but maybe let's split it into how did we get here, and then later on we do like where is it going, right? So I guess at the high level, I kind of joined this world as a vendor, as it were, right? At the cusp of NoSQL, right? Neo4j was founded back in 2007. We had a couple of years, right? And then NoSQL happened summer of 2009, right? And prior to that, I was a user of data products, right? But not a producer of them, as it were. And I think kind of walking into the previous decade, like there was this explosion of experimentation, right? This was on the back of, I feel like it got kicked off by, Amazon's Dynamo paper, and then, just a few months after that, Google's Big Table paper, and just the observation that the big web giants, they didn't run on the relational database, right? And so that created this massive divergence, right? There's a site called DB Engines that I'm sure many people who listen to this podcast would be familiar with, but they track a bunch of signals around database projects like tweets and Stack Overflow questions and Google searches and stuff like that. And they're now tracking over 350 databases. And when I grew up as a professional developer in the mid 90s, there's like a handful to choose from, right? Sybase, Informix, Oracle, DB2, whatever, MySQL, right?
And don't forget SQL Server.
The SQL Server, right? Well, yeah, that's right. Yeah, and honestly, there's like 98.7% the same product, and that's a scientific statement. No, but it's like basically the same product, right? And then on the margin, there's a little bit. So it was basically a vendor choice. And then fast forward to kind of the early parts of the previous decade, all of a sudden it's like key value store this, and document database that, and graph database this, and time series database. There's just explosion of choice. And I think there's a number of reasons why that happened. First of all, I think that the only time when you can take a new database and bring it to the market is when you have a platform shift of a kind. If we think back to, the shift from mainframe to client server, that was really, what built Oracle, right? What enabled Oracle to be built, right, in the relational database. And then we had kind of client server to web, and that's where MySQL was born. And if you look at kind of where we are today, I think there's two broad platform shifts, the shift to the cloud, and then the shift to mobile. And mobile hasn't really given birth to a new database. Couchbase tried for a while. Realm tried until they got acquired by Mongo. But there really isn't like a new kind of, this is the database for the mobile platform, right? But of course, the cloud shift has enabled a bunch of them. So I think that's a big driver. And maybe let me pause. This ended up being a long monologue, but like that's one. I think there's 3-4 other key drivers that caused this explosion of choice in the early part of the previous decade. But let me pause there and see if you guys even agree this far. Also, pause to drink some of this delicious beer.
Well, I think it's an interesting statement, and I agree with, is that at the beginning, it was just always these 5-6 databases, and that's it, right? I think, remember the LAMP stack, right? Linux, Apache, MySQL, yeah. PHP, like that. I mean, that's how everybody got involved with that was a simple, easy, free way to go get involved with databases. And that was it, right? And then one day, like I'm growing up, I get out of MySQL and I use either SQL Server or Oracle. That was it. I mean, even DB2, like you use DB2 because IBM made you go to it. But so that's a really good observation, that it was just the vendors, right? You just had this one thing, and all these vendors sold the exact same hammer, just happened to have this different label to it. But the kind of the whole NoSQL thing is people started getting kind of annoyed with SQL, right? It was, first of all, it was NoSQL, and then people were like, well, it's not only SQL, and then kind of the whole, what's so ironic is that now we put SQL layers on top of the NoSQL. Now everything has a JDBC driver and stuff like that. So at some point, and a lot of people I do talk to is like, well, SQL is still going to go prevail, right? It's not going to go anywhere. But then we have 350 databases, so it's not true or not. I mean, how the heck do we get to 350 different databases, and what are those categories? I mean, this is ridiculous. Do we really need all those different types of databases?
Has the specialization been a good thing?
It's a good question, right? And so, like, how did we get here? And then, is specialization good? I think there's probably three components that I think of, right? One is kind of an enabling force, and I think of the shift to the cloud as one of them. That introduced new architecture patterns, things like microservices and containerization, which shifted us more away from this big monolith, right? Where if you wanted to, for whatever reason, like if you wanted to switch out your database, if you have a massive monolithic type architecture, it's more costly, it's harder, right? So the value has to be bigger in order to even switch out your database, right? And so that's all kind of on the enabling side, as I think of it. And then I think of like there's a pressure side, or maybe I sometimes think there's a supply side, and then there's a demand side or a value side. On the pressure side, then it's just I kind of hate the term big data. I always hated it, but like just the proliferation of like massive amounts of data, and it's driven by all these sensors that we carry around in our pockets, and just so just more and more data that is more and more complex, that exerts huge amount of pressure against the existing model, which at the time was just the relational database, right? So I think on that kind of on the pressure side, so that's the second bucket of forces. The first one was the enabling one, and then the third bucket of forces, I think, is on the value side or the demand side, right? And here's where things like AI and machine learning come in, which is, of course, like this massive secular shift, which goes even beyond technology. That's a broader societal shift, right? And that, I think, speaks to the value of using different types of data stores, right? So I think those are the three driving forces, and a couple of examples in each of them. I do think the specialization served us as an industry well, and maybe more so the experimentation, right? Because like when you have a chance to get like orders of magnitude betterness, like for some definition of betterness, like more agile software development, developer productivity, or performance, or scalability, it just unlocks new things, right? And if you can get that for your application or a slice of your application, right? Coming back to the microservices piece, it doesn't have to be for the entire application, but if a slice of your application can be orders of magnitude better, all of a sudden you can leapfrog the competition, create much more value for your users, right?
Yeah.
So I think that was just really valuable for the industry at large.
It's like, as you know, as you're stating, I don't love the term either, right? But like as big data happened, as unstructured data and its various forms, right? Fast data, streaming data, geo data. I mean, you think of sort of the specialization of data and the quantity and the complexity and all these things, right? It's like this environment made specialization become really beneficial, because even though, obviously SQL was this hammer that you could use to hit a lot of different things with, people were like, well, but it's not really great at search, and it's not really great at working with JSON documents, and it's not really great at like dealing with events, right? It's good for transactions. And so you had this kind of explosion, and obviously we'll talk about graph as well. I think that's super interesting. And just as a reminder to our audience, because I know that we've got a lot of folks listening right now, feel free to jump in with questions, and we're starting to see them pop up on the screen here. So definitely feel free to add your questions live.
Yeah, and then I think there's this tension, right? Because kind of in theory, with what we just said, right? Like if a component of your application can become a 10x or a 1000x better, like let's just use performance because it's such a stark thing, like 1,000 times faster, right? Like why wouldn't you do that all over the place? Well, there's this tension, right, in the real world because you don't want to introduce 13 new data stores in your application, right? Because that's just a management nightmare, a skill set nightmare. Like it's just all kinds of problems, right? And so then there's this tension between, right, all right, maybe using exactly one for the entirety of my company. That's not the right thing to do. That's kind of the world we lived in the 90s and the early 2000s. But we're not going to use each and every one of the 350 either, right? And so there, and I think as an industry, we're still figuring that out. Like how many is it appropriate to use? And I also think that. No, go ahead. Go on.
Sorry, on that vein of like which to use in the spectrum. This is really interesting. I want to go navigate this spectrum. The first reaction I have is, well, the two sides are OLTP and OLAP, right? I got transactional data, and I need to go manage transactional data. I manage analytical data, and then within each one, you have a bunch of more specializations. I would argue that for the types of transaction applications that we do, it's always the relational always will be kind of the winner there. I believe. I want to hear what you think about this. On the analytics, I think that's where things are going to see much more. That's we're seeing more special types of specializations. How do you see this space right now between OLTP and OLAP, kind of before and where we're going on this?
So I think success, when I go to conferences and I participate in panels, I think panels are generally the lamest and most boring part of a conference, right? Unless there's a disagreement on the panel. So I'm going to carry that philosophy forward to a podcast and say, I completely disagree with you, Juan. On both of those statements. So I do agree with the split between kind of analytical and transactional, but I actually think we're going to see a convergence. And maybe this is a segue to speaking about like kind of where the world is going, right? If we talked about kind of where we've been, okay, where do we believe it's going? And at least the way that I think of it, I also think of it as this broader split between operational data stores, right? So these are used by developers to build applications. The applications use the data store, right? That's an operational data store, OLTP, right? And then analytical data store, right? Which stores historical data, and it's used by data scientists really to, air quotes, build machine learning, build AI, right? Or for data analysts to build reports, really. And if we start on kind of the right hand side, on the analytical data store side, it's system of record for history. That's kind of what they're doing. And the question is, what are you using that history for? And the way that I look at that landscape today, we've had for maybe 2, 3, maybe 4 years, we've had 2 product categories. One is, let's call it the data lake dynasty, right? So this is really led by Databricks, right? And it's the primary user here is the data scientist, and it's very code centric, right? So that's kind of one category. And then the other category is, let's call it the cloud data warehouse. So this is Teradata in the cloud, maybe, right? And the primary user here is a data analyst rather than data scientist, and it's more SQL centric rather than code centric, right? So those have been the kind of the two paradigms, and the leader here then is Snowflake, right? And of course, all the global cloud platforms have implementations of this. For example, Redshift and other things like that, right? So that's kind of that part, right? And what's very clear right now is that those two are converging into one, right? If you look at the features that Snowflake is launching right now, it is squarely targeted to the data scientist persona, and they're very code centric, right? And some of that is core features in Snowflake itself. Some of that is deep integrations with the cloud platforms, but it's very much targeted to like the sweet spot of the Databricks use case, right? And if you look at what Databricks is doing with they call it the data lake house pattern, right? That's adding schemas on top of the data lake, which all of a sudden, and you're a world-class expert at this as Juan, right? Like that, the schema gives them an opportunity to build a query language, right? Build a query planner. And so all of a sudden they can add SQL on top of that, which is squarely targeted to the Snowflake kind of sweet spot use case. So I actually think they're going to converge. And I think the stable state here is actually one category on the analytical data store side. So let me pause there. I'd love to talk about the operational side as well, but that's actually how I see that one kind of over time.
So the data warehouse is becoming the data ware lake, and the data lake is becoming the data lake house, and maybe it'll get a little wary in there as well. Those things are converging, right? It's like your structured data wants to be able to support more unstructured data. Your more unstructured or code-centric approach wants to be able to handle these analytical applications, right? Like your Tableaus and your things like that. You want those to be able to work well with Databricks too. So those are kind of converging, is what you're saying.
Nothing controversial here. I think I completely agree with this.
Damn it.
I'm waiting.
I tried to be disagreeable.
Well, no. So I think
well, on the transactional side, it sounds like maybe there's a little disagreement.
I think so. That's where to get interesting. But I think a very valuable kind of insight here is the data lake, the Databricks, right? They're data scientists, they're code centric. The cloud data warehouse or the data analysts are the SQL centric. I think the cloud data warehouse, like Snowflake, they're just taking your traditional old school oracles that people have been doing, and they're like putting it in the cloud, right? The storage.
Teradata in the cloud.
Air quotes, putting data in the cloud.
Yeah.
But I mean, at the end of the day, putting things in the cloud is supposedly make things easier or better for the business, right? I mean, that is yes, fully agree with that. Fact.
Yeah.
Scientific fact. All right, so let's go into some controversy. What's on this operational side?
So I think that on the operational side, I think that there's 4 segments emerging here. I think the relational database is underlying it all, right? And we can talk later on how I think it's going to unfold in terms of relative weighting of the different segments, right? But the database market today, it's the biggest market in all of enterprise software. It's a $50 billion market. And it depends a little bit on who you're asking, but if you talk to the Gartners and the IDCs and the Forresters of the world, it's expected to grow to 100 billion over the next 4 to 5 years, either 2024 or 2025, right? So that's $50 billion of incremental market cap, and that's like real spend by enterprises primarily all around the world, right? And everyone is agreeing that most of that, if not almost all of that, is coming from the new, right? That is not Oracle. And if for those of us who's kind of studied the database market 5-7 years ago, it was a mature market growing at 5 to 7% per year. And now the growth has skyrocketed, and it's all driven by these new segments. So what are the new segments that at least I see, right? I think there's 4. One is what I call document plus plus, right? Again, air quotes, right? That's just my name for it. And this is the old kind of document category spearheaded by Mongo. But what's very clear to us, at least here at Neo4j, right, which is when we're out talking to customers for a single project, it's a zero-sum game between Mongo and Couchbase, obviously, because they're a document database, but actually also Redis Labs, right, with Redis, and DataStax with Cassandra, right? So they are competing for the same architectural slot in the same project, even though they have a little bit of a different, like they have different data models, right? But still, they solve the same problem. That's actually the definition of a product category. So I think they are the same product category, right? Led by Mongo, right? So that's document plus plus.
So the problem that they're solving is to just be able to go set up an application, a product very quickly, and one single application silo, another database. But if my goal is to go create an application as fast as possible and scalable and all that stuff, just use a document database.
That's exactly right. So that's the first one. document plus plus. The second one is graph, and there's no like order in between them, right? This is how I'm thinking about it. The second one is graph, and obviously I've made my career. I'm massively optimistic about graphs, and we'll talk more about that later. And we can talk about the relative weighting between the categories, but that's the second one. The third one is time series, which is clearly differentiated. Now, Mongo just launched time series functionality actually a couple of weeks ago to great fanfare. I'm not an expert at time series databases, but I'm looking at that, and everything in it feels like when all the database vendors added graph as a feature, which MongoDB did in 3.4 with the graph lookup operator. DataStax acquired Aurelius and added a layer on top of Cassandra for graphs, and Cosmos tried to do that on top of their from Microsoft on top of their document database. None of that worked. That all went sideways and didn't end up working, right? And when I'm looking at what Mongo is doing with time series, it feels very much like that. I think that's going to be won by InfluxDB or Timescale or one of the purpose-built native time series databases. So that's the third category in my mind. And then the fourth one is Use SQL, right? So this is basically, in my mind, kind of Google Spanner inspired, massively scalable cloud native relational databases. So this is the Cockroach DBs or the Yugabytes of the world. So those four categories, document plus plus, graph, time series, and Use SQL, is going to be the majority of the growth in the database space over the next 4 or 5 years. And that's what I'm personally excited about.
So you feel like, based on your statements around sort of the time series segment, as you're looking at the space, you're kind of seeing these four specializations as being their own there's their own optimization that happens within that specialization. That when you start to do things like say, hey, I've got my MongoDB and I'm going to throw my graph on top of it, or I'm going to throw my time series on top of it, or you say I'm a time series database, and oh, by the way, you can store regular objects in me or something like that. That you're now breaking what feels to be these sort of like operational optimization areas.
Yes. I'm looking at it from two axes. One is value to the end user, and the other one is how hard is it to bolt on to an existing system, right? And I think time series, for example, is very valuable for the end user. And it's really hard to bolt on to an existing kernel. Like, for example, at Neo4j, if we would try to do time series really well, we would have to do so many awkward things with our kernel. And I'm talking like very physical things, like how do you lay out data on disk? Right? How do you structure it in memory, right? That in reality, it would be one of those classic engineering trade-offs where we wouldn't be as good for graphs anymore, right?
Right.
Now we can all fake it. Like these are all isomorphic models, which is a fancy way of saying you can serialize data in one form to the other without losing data, right? And so you can also always fake it. I can fake time series and model it in a graph, and stuff like that. But that's not what I'm talking about. I'm talking about doing it with real performance and real scale.
Right.
Yeah,
and
if
you're
you want to have
talking
a
about
checkbox, that's it.
Oh,
It's
go
easy.
ahead, Juan. Yeah.
No, if you just want to have a checkbox, everybody can do everything.
Exactly.
Right? But no, you're talking about who really own it. Yeah. Sorry, Tim.
Right.
Exactly.
And not just sort of having a company own these things, right? So you, like, for example, let's say MongoDB buys Influx or something like that, right? That is just because it's part of the portfolio doesn't mean that it's all part of the same database.
Exactly.
And is this good for like application developers? Like when you think about like, hey, I'm going to build this application and it's a relatively complex application and it has time series elements, it has document elements, it has, one thing we haven't talked about, I'm curious which bucket you feel like it falls into is like search, right? Where, the idea of like Elasticsearch and things like that. Is this a good thing? Like, like you kind of, sometimes you need to combine like 2, 3, 4 things together to solve your problem. Maybe that's okay. That's the new reality.
I think the goodness has to be evaluated with a business lens, right? Like, what's the value of the problem that we're solving, right? If this allows us to solve like a business problem that was previously like untractable, like we couldn't solve, and is really valuable to the business, right? Then I think it's a great. And you can do it because you can compose these different backends, then I think that's a fantastic thing. But if you purely look at it entirely just from a technical perspective, it probably isn't, because there's more moving parts and that's more complexity for the developer. But if it's in pursuit of something that is very, very valuable, I think that's what makes up for it.
So I want to keep graphs in separate right now because we're going to dive more into that. So the use cases are kind of the reasons why you would go for a document time series in Use SQL. I guess in graph too. You talk about documents saying, well, if I have a single application, I want to develop fast and have a very scalable solution, document. But if I'm using more, I got more sensor data or stuff, like I would use more time series. So when would you want to go use any of these 4 categories you were talking about? Because technically, let's take time series out. You can probably you can come up with any application and say, well, you can give reasons you should use document for that. And you can also give good reasons why you should use a graph for that. So how would you even select out of that?
I think it's back to the shape of the data and the shape of the workload, the queries on that data, right? And if it's data, like if it's, to your point, like, I don't know, stock ticker data, like once every second we're reporting the value of the stock, right? That feels very time seriesy. And if you look at that, it's like, well, what we want to know is kind of the average of the past, minute, hour, day, wow, that's a very kind of time serious workload, right? Then it fits really well with that. Hey, all my developers, they already serialize my data as JSON. Man, that seems to fit really well in a document database, right? And so I think it's back to it's the shape of the data and the workload on it.
That's agreed. But so when would you use SQL? Guess for all just like the code just the normal transactions, or I mean because all these transactions you can store also in the document, you can store in all these things, right? So I'm now curious to see where do you see SQL going?
Is SQL just an old habit dying hard?
I think there's some of that. I'm not. I think one thing you said before, Juan, was that you believe, or maybe you just kind of wanted to be provocative, saying that SQL will be around forever and will be the dominant paradigm. And I actually don't see it that way. I think that right now it is, but like if you look at the number of applications being written with SQL as a backend today versus 10 years ago, it is dramatically different. And my prediction is that 10 years from now, it's going to look a lot different too, right? And I think it's because there's a lot, if you set aside kind of the analytical, if you set aside reporting and things like that, right? There's very few domains who are inherently table oriented, right? And the way that I think about this is that, like, when you're kicking off, at least, back when I was technical, which I'm no longer, right? But like back when I used to write code for a living, right? And you would, as a consultant, you would build a new system for someone like in the enterprise, right? Day one, you get into a room, tons of whiteboards, you have a bunch of domain experts, and you just say, all right, tell me about your world, tell me about the domain, tell me about the application. You started whiteboarding that, right? And they started talking about pensions or insurance or whatever the domain that they were experts at. Almost never did they end up intuitively drawing tables on those whiteboards. They might, if it's, for example, a payroll system. It's like first name, last name, I don't know, role, salary, something like that. Like, okay, that's an intuitively tabular, data set, right? But most of the time, it's like we have a shopping cart. Inside of that shopping cart, we have order items. Those order items refer to a product. That product, like it's a book which sits in the product hierarchy, like might be a science fiction book, which is a fiction book, which is a book, right? That very infrequently ended up being tables, right? And so if I think about kind of just all the applications being written out there, I think there's like a mismatch, a cognitive mismatch between the building blocks exposed by the relational database. Now, it'll still be around. Like when we retire, screw it. Like when the three of us, when we die, the relational database will still be around, storing information, that kind of stuff. It's not going anywhere. Mainstream, whatever. Mainframes are still around, and COBOL is probably the most popular programming language if you start looking, or something ridiculous like that, right? And so it'll still be around. But if I look at new applications, I don't think most of them will use a relational database as a backend.
So this is going to be a good segue to graph. But before we get there, a couple things. I saw a talk by Bob Muglia, right, the former CEO of Snowflake, and
yes,
and it's all about relation always wins. And he's actually talking about the relational knowledge graph. And there's this friends of the company,
relational.ai.
Relational AI, right? They're about the relational knowledge graph and stuff. So I think I'm now thinking we need to have a panel where you put you guys here. This would be a fun one, right? So that's one thing. So I think I agree with you that relational always exists. I mean, it's not going to go away. But I think there's always going to be the type of workload, the type of there's types of data that will always be tabular. So for example, I agree that we'll have, an order has an order line, an order line has a product goes into a shopping cart, and all that stuff. But when you go into the details of what is an order line, that's just tabular data. I mean, at the end, I just want all this stuff. It's just the relationships between the main things end up being more, or you draw them on the whiteboard as a graph. That's one thing. So I think when people say graph, why graph? If I can do this in relational, you can do whatever you want in a Turing complete language. I don't care about that. It's like at the end of the day, it's not about one or the other. I think it's going to be about a convergence. We got to understand how it's not graph or relational, it's graph and relational. And I think there are pieces of data that are naturally going to be tabular, but the relationships between them, again, relationships, connectedness. I think that's how I see it. So it needs to be a combination of those two things. And the other part is that when you start doing the analytics, I want to do an average, like that's tables at the end of the day. It's like, I just want to go sum everything in this column, right? So I think tables are going to, I think one is how I'm building applications and storing the data for those applications. And what's the best way of managing that? And I definitely agree that the graphs is the way to go do this, because that's how you think about it in your head. That's what you do on the whiteboard. But when you're actually using the data to do some sort of analytics, or kind of like traditional old school analytics, it's still reporting on tables. Now we're taking it to the next level, and you want to go do things that are in graphs and stuff. So, which takes us to the topic about graphs, which up to now we've been talking for like half an hour and haven't touched on graphs on purpose. But let's get into graphs now, because heck, that's your life. That's my life.
The main course, huh?
Yes.
Our main course. They're in the main course now. Graphs. Where should we start?
Take a
There's
sip
so
of beer
much
before
amazingness
you
to talk
jump in.
about, isn't it?
Okay, so let's start with why are you fascinated by graphs? Like, why did you decide to go focus your entire world, life, company, everything around graphs?
So a couple of things. Well, very precisely a couple of things. Two things. One comes back to maybe dovetailing off of the conversation we just had. As a developer, I just found that to be the most intuitive model to express most domains, right? For those of you listening in to this podcast who is not doing it commuting, like whatever, just audio only, if you're at a computer right now, go to images.google.com, search for domain model, right? Which is the way to express an application, right? When you're building a new application, search for domain model. What you'll see, there is a page full of example domain models. Keep scrolling. Every single one of them you'll see is a graph. Every single one of them. Go to the Wikipedia page for domain model. Right there, it has a US healthcare one. It's US healthcare because it's very complex. And it's a big graph, right? I think all applications are graphs, right? It's objects connected to other objects, and they're connected in various ways. And I just found that to be the most friction-free way to translate the domain model into something that a database could operate on. So that was kind of the first one. The second one was the observation that, and I guess this is a podcast about data, and beer, cheers.
And cocktails.
Yeah, and cocktails. Sorry, cheers. And the question is, what is data? This is the second reason, right? What is data? Data is actually a fairly abstract concept. Like, you ask people, what is data? To me, data describes the world. It describes the real world, right? And what is very, very clear in terms of one of the most secular trends in the universe, at least on our planet, is the world is becoming increasingly connected, right? I say on a podcast recorded from 3 locations, in the world, I sit here with 2 phones, with 2 AirPods. Like, my car is 150 plus computers embedded and connected in various ways. There's 4 SIM cards connected to the internet, right? Everything is becoming more and more connected. And if you add those 2 things together, data describes the real world. The real world is becoming more connected. There's going to be more and more connected data in the world, right? And so I felt, and graph databases are the most amazing piece of technology for figuring out how things are connected. And if that's true, then the drivers, the reason to use a graph database is just going to be more and more every day, right? And so you add those 2 things together. That's what ultimately made me so excited, why we created Neo4j, the product, and ultimately Neo4j, the company.
Before we get too much into the graph tech side, I mean, obviously you've been doing this for a while, and you just talked about sort of the inspiration that led to it. Let's start with the business use cases, right? So what would you say, is the business value of graph? Like, you're trying to convince execs to invest in graph database technology. Like, what use cases are you pointing to? What ROI are you pointing to?
Yeah, I think when you talk to execs, I think it's 2 levels, right? Depending on where they sit in the organization, right? If it's absolute top level, like board level, CEO level, CIO level, it's aligning to massive broad trends. It's back to, and I apologize on a no BS podcast for using this term, but it's back to digital transformation, right? You're shifting all your business to become digital.
That's
You need
okay.
a
We'll
platform
bleep
for
it out
that.
later.
Yeah, exactly. And you need a platform for that. And graphs built some of the most amazing, billion, $trillion companies on the planet. Facebook, Google, that is all the underpinning of that was graph technology. We give you that for the normal enterprise, not for the web companies, right? So that's kind of the highest level pitch to like boardroom level, right? A more common one is for, let's call it, mid-level line of business execs, right? And then it's about taking a very specific business problem. It's not talking about the technical stuff at all. None of what we've talked about so far in the podcast. It's saying, dear director of risk at a big bank, right? You know what? Your fraud detection software today can capture a lot of bad guys, right? But you know what they can't capture? It's if you have a number of transactions, none of which are anomalous, but they're connected in a way that is anomalous, right? Which is, for example, a fraud ring, right? The only way you can do that is being able to operate on connected data, right? And the only way you can do that is by using a graph database. So let's have a conversation. Let's spin up a project. Give me, and I'll make up some numbers, $1 million for my database, 5 million for the project. 6 to 9 months down the line, we're going to augment your existing fraud detection solution with a way to capture fraud rings, which will increase your ability to detect fraud by 3 to 5%. Right. So that's a very business level, type thing. But then it's the same for, retail like real-time recommendations, for example, in retail, or, identity and access management, or you just go down the list of the kind of the classic business problems that graphs solve today, of which there are n amount today, and n plus 1 tomorrow, and n plus 2 the day after tomorrow. There's just more and more. because the world is becoming more connected and more business problems require or at least benefit from being able to operate on connected data.
I love that way of approaching it, and I know Juan and I in our notes here are like yes, because we agree with a lot of how you're sort of pitching that, and in what you just said there, right? Graph database could be replaced with X, right? And X could be whatever is providing that value, and I love that you're resonating, you're speaking the right language to business people if you can replace whatever it is with some other word or phrase, and really it's about the business value.
That's exactly right.
So, well, we're seeing here on the chat kind of some of the technical questions that I knew we were going to go get anyways, right? The whole convergence of different graph stuff, and I think I'm going to bet that we're here on the same page on this one, which is it's not about the RDF versus the property graph. At the end of the day, these things will also converge. Well, that's my position. I'm curious and that what your position is right now.
Yeah, so this is probably an area like I mentioned when we talked before. You'd school me on this topic, but I think we probably do disagree here, right? I think RDF. Yeah, I think so, right? I think RDF was a massive source of inspiration for me. And before we built Neo4j, I spent a lot of time in RDF land because finally someone saw the world as a graph, right? And it was just it just clicked with me on such a deep level, right? The concept was fantastic. The implementation was horrible, right? And it was so clear that every single software that I bumped into, every API that I bumped into was written by someone whose primary deliverable was an academic paper. And as a side effect, they had to write some software, which meant that the APIs were kind of whatever and stuff like that, right? And as a developer, I just felt tortured. There's so much friction between me and that beautiful graphy data model, right? But you had to go through all this pile of crap to get there, right? And
yeah, that was 15 years ago. That was 15 years ago for sure.
And I think that's so. The question then is, how much has it improved? And I think it probably has improved significantly, but still, I feel like the massive benefit of the property graph model and why graph databases took off, I will immodestly say that it is thanks to property graphs, not thanks to RDF.
I know.
Right?
I will definitely. I publicly say this is thanks a lot, not just to the Neo4j and the property graph, also to your gigantic marketing machine. That I mean, and your grassroots approach to this, right? I mean, that was beautiful.
Yeah,
that's
and Neo4j and others, right? Like Neo4j and other vendors in the property graph space, right? But that real focus on the developer and developer productivity, where I would rate as, C or something like that, right? And something like Mongo or MySQL is like A- or B+ or something like that. I think there's a lot that we can improve here, by the way, right? But I think RDF was never even a C, right? And I think that held people back from what I think is this very intuitive and powerful model, right? So will they converge then? Maybe. I don't know, right? There's parts of me that is nervous about RDF's prominence because I just have this scar tissue of developers wanting to get to graph data, encountering RDF, having such an awful experience that they end up getting turned off, right?
So I would argue that I think the position that you're talking about was definitely spot on for things that were 10 years ago. I think it's changed a lot in the last 5 years. And we don't have time to go into. I think that's another type of podcast episode we can go have. But I'm very happy with the work that, for example, Jesus Barraza from your team is doing on the right? I mean, that's just showing you how that stuff is converging. And then you have things like Neptune who are doing both Sparkle and Gremlin, and they have Cypher, open Cypher support.
Just launch Cypher, yeah.
Yeah, so I think that's how I'm seeing more and more of these tools. I mean, you're seeing other databases. I mean, Anzo and Stardog, they're also supporting some sort of the property graph, right? Can they do that better? Yes, there's biases, of course, but I'm just like, I'm seeing these kind of convergences going on, and also in the whole standards and the whole GQL standards and the property graph schema working group, which I'm the chair of right now. Like, we see how you bring in all those things that the RDF world has done in, and like, yeah, we're converging to it. Actually, there's a knowledge graph book coming out, or from O'Reilly, from Amy and Jesus, and I actually reviewed it and wrote the forward for it, and I loved it. And it's just showing more of the convergence about it. So I don't know if you've read my forward yet, but hopefully you will, and you will soon. And I think,
I've not read your forward yet, but there's another enterprise knowledge graph book coming out too, right? Not to be forgotten.
There's one that came out this
by
week.
You.
Yeah,
exactly.
Right.
Right.
All right. I think we're getting kind of on our producer is telling us that we got to look at the time right now, and we got some kind of wrap up stuff we want to go do. Emma, we could just sit here and talk for hours, and I just can't wait for us to go do it. We should probably do this again. We have to do a graph update, or the next version of this
Redux.
Yes, and focus exclusively on graphs. But let's go into our little lightning round, which you have no idea what we're going to go ask you. So
I have no idea.
All right,
but
so
I'm drinking great beer, so I'm not afraid. I will charge ahead.
All right. So first question. So many people know SQL in the world. Will there be a day that same amount of people actually know a graph query language?
Absolutely. There's no doubt in my mind.
All right.
Nice. Direct. All right. Second question.
I thought it was yes/no question. Like, I'm happy to expand on it. but
you can add a little color. Feel free to add a little color.
No, it's back to the trends we talked about before. Everything is becoming more connected. So the performance and scalability driver of graph databases, which was the primary driver of graph database adoption in the previous decade, and will remain a really important driver in this decade, but it's not going to be the primary one. But that driver, that pain will increase as the world is becoming more connected. Data sets are becoming more connected. Your competition is going to use connected data queries, which means you're going to have to do it, because otherwise they're going to be the Google and you're going to be the Alta Vista if you can't operate on connected data, right? So that, along with the other driver, right, of this just being a domain, a better fit for most domain models, means that I actually think there's an opportunity. It's not guaranteed, it won't happen naturally, but if we at Neo4j and other graph vendors play their cards right, I think there's an opportunity for graph databases to be the first database that developers reach for when they're building a new application.
I love this. You want to be the Google or Alta Vista? Go, Tim.
Exactly.
Another one.
Well, I think about the 80s and how that's so popular, the retro thing. Maybe Alta Vista is kind of cool now. It's retro, right? All right. So I got a question for you, and then I think we may need to move forward just because of time constraints. So will the majority of new business applications 10 years from now, so majority, over 50%, be built on graph databases at the core?
Yes. And that's what I just said.
All right. I got it. Let's do quick on this one. This is a funny one. Did you really come up with the property graph model on a plane to Mumbai?
Yeah, so this is where like kind of marketing simplifies things, right? So I first drew the model literally on a cocktail napkin, right? Like with nodes and relationships and key value pairs on both, right? But then we had an intense week with that team where we really refreshed it and all that kind of stuff. But that usually gets lost in kind of the simplified marketing version. And then in parallel, folks like Marco Rodriguez had built this out without having seen our stuff, right? He built it out for his stuff, which ultimately led to Tinkerpop, a couple of iterations down the line, right? But yes, on that flight to Bombay, I was like, all right, I need to stay ahead. Like, these guys are really smart. I need to think a little bit. What are we trying to build there? And I drew it on a cocktail napkin, what people today call the property graph model.
All right. Well, hey, takeaway time. Tim, Tim takes us away with takeaways.
Yeah, I mean, there was so much good stuff. I mean, we say that every single week. We're very blessed with our speakers. I mean, one of my big takeaways is around your assessment of the landscape, right? Thinking about sort of the divergence of the transactional or operational database space, but how these specializations are really useful. And then on the analytics side, how you've got sort of the data lake and the data warehouse, but these things are converging. But ultimately, all of these things are tools in the tool chest that you have to make the right choices for to optimize for your particular business use case. So I think that's very helpful. And what about you, Juan?
You're very concrete. The four things you're seeing: Document++, Mongo, CouchDB, graphs, time series, new SQL. That's where the world is going. How do you know which one to go select? Understand the shape of your data and your query workload. That way. Back to you, Emil. Very quick and short advice. Two questions. One, what's your advice about anything, life, data? Second, who should we invite next?
Just advice generically, like any advice.
Any advice?
Anything you want.
Oh my god, that's that's very broad. Well, okay, so let me maybe segment it in three different ways. Then advice to I bet we have other kind of fellow startup founders, entrepreneurs, that type of an audience. And one of the things is, first of all, ignore advice, right? That's what I've gotten a lot of advice. I've listened to some of it. I've ignored most of it, right? So that's kind of the first one. The one thing though that always is true is there's no way for you, dear fellow startup founder, to over-index on understanding the customer. Like, that's the one thing. And when I say customer, I mean the actual user of your product, not the economic buyer. Yes, they're valuable. Not their boss. Yes, they're valuable. Not freaking procurement. Yes, they're valuable. But understand the actual user of your product. There's no way you can spend too much time doing that, right? That's the one advice for startup founders. And then I think, I think general work advice: surround yourself with I mean, you're the average of the 5 people you spend the most time with, right? So find the brightest people, no matter what the role is, no matter what the pay is. Just find the brightest, smartest, most well-intended people that you can. I think general life advice, I sometimes get asked this these days, as if I had any clue what I'm doing. But I think the one thing I will say though is I feel like people are really under-indexing on choosing their life partner. I feel like I find really thoughtful people who like they take such considerate blah 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 blah, and then they marry the person who they happen to, in Sweden, like they happen to be, dating when they're in their early 30s, and probably in the US it's earlier, like mid 20s, right? I'm like, what are you doing? Like, this is probably the number one decision that will impact your life the most, is your life partner, right? Man, don't take that decision lightly. So my improvised 3 slices of advice, since you gave it me like a very broad umbrella.
Choosy, everyone. Just because you hit 33 doesn't mean you have to choose. You have to marry, right?
Exactly.
Right. 30 seconds. Who should we invite next?
You should invite Jeff Jonas from Sensing. If you haven't had him on, like you know that I listened to many episodes of this podcast even before you invited me. I haven't listened to all of them, so I don't think you've had him on, but I don't know. No. But Jeff Jonas is founder of a company called Sensing. He's one of the main thought leaders, if not the main thought leader, in ER, entity resolution. I think he's the only IBM fellow to ever leave IBM. I think that's true. And it's just like one of the smartest people ever in data. Get Jeff on the show.
Awesome. Emil, a pleasure. Thank you so much. This was an amazing conversation. I think we're gonna have to go do this again, just focus 100% on graphs on that next time. Cheers. Thank you. Enjoy sweet, enjoy your beer. And next week, we're going to have Denise Gosna, who's the CDO of DataStax. I talked to her today, and she sends a lot of best regards, and going to continue the conversation about graphs and data and open source.
Another graph enthusiast.
There Fantastic.
We go. Databases Cheers. For the win.
Cheers.